Hey everyone. Now that we've looked at slope and remembered how to use equations and tables to graph the linear equations, I want to take a look at problem 4.3. I sent you home before we left with lab sheets for 4.3 that look like this. And we don't have everything that we might want to write on the lab sheets in terms of space, but we can use the sides and kind of improvise a little bit. So one thing that I want to talk about that I didn't mention before with slope is that if you have a coefficient of 3, for example, it's really the same as having 3 over 1, because the change in y is going to be 3, and the change in x is going to be 1. Anytime you have a coefficient that is a whole number, you have to imagine that there's always this 1 underneath and you turn it into a fraction. That way you know how much to change y when you change 1 of x. So let's take a look at the very first one. And so all you need to do is plug in the numbers for x to know what y is. So if x was 0, 3 times 0 is 0. And if x was 1, 1 times 3 is 3. X was 2, it would be 6, and it would be 9. Just like going the other way, it would be negative 3 and negative 6. So then we could call this one purple, and we could graph that. So we could see that if we had point 0, 0, our next point where x is 1, y is 3. Let's do another one, 2 and 6. And we could use our magical tool to make a straight line that shows what that slope is. Pretty close. Try that again. That's better. Okay. All right, so in the next case, we know that, again, our slope is going to be 3, but now, notice, you have this first number, which is the y-intercept. So I'm going to change colors here. Let's make this one red. And so we know we have the same slope, but it's not going to start at 0. It's going to start at 5, because if x was 0 right here, y would be, well, 3 times 0 is 0, plus 5 is 5. And if x was 1, 1 times 3 is 3. Just always imagine putting that number right next to the 3, right up there. Okay. So in this case, it would be 8. Notice it's going up by 3, so you're going to find a pattern. 2 times 3 is 6, plus 5 is 11. Notice they're going up by 3s, all right? So this one's 14. And in the reverse, they're going to go down by 3s, so that's going to be 2, or 2 times 3 is 6 minus 5, because it's a negative. Negative 6 plus 5 is, 6. No, this is negative 3 plus 5 is 2. And then this would end up being negative 1. So in that case, 0 and 5, 1 is going to go all the way up to 8. 2 is going to go up to the 11. Notice you're going to end up with perfectly parallel lines. And that is because you have the same slope. All right. Notice the next two equations also have 3 as the slope. So they're all going to be parallel. But this one, if we made this blue, it's going to start at 10. You're not going to have a lot of space to make this graph, but it's going to go up by 3s, like something like that. And this one, let's make that one green. That starts here at negative 5. So we're right down here, same slope. Now you guys are going to fill in these tables, but you can see what the pattern is. And they're all, if my lines are good, they're all going to be parallel. All right, that's it for now.